getting ready to... Hey!
Thank you all for coming. We have today Dr. Sathish Santharam, and he's interviewing for a part-time instructor position, and this is to teach our two design courses to undergraduates, one in the fall semester and one in the spring semester. He's one of our own Ph.D. graduates, so it's a pleasure to have you back. And he'll talk for, I think, like 20-25 minutes, and then take your questions. And if you have feedback, I'd appreciate if you'd write me your impressions and thoughts and comments, and that would help also. So, okay. That's okay.
Grant.
I think it's probably there. Okay. Yeah, bunch of is it okay? Okay, that's fine. Thank you, Dr. Edgar, and it's a pleasure for me again to come back and present here. I did the same last year, and last year my topic was wastewater treatment lagoons in Kansas, and I talked mostly about lagoons, but now based on the course requirement, I just tweaked this presentation a little bit and add the process engineering design approach for wastewater treatment lagoon. The outline of my talk is going to be two parts. One is overview of lagoon. First, I will explain to you what a lagoon is. You're all probably mostly chemical engineers, and I'm a chemical engineer too, but most of my work experience is on the environmental side. So if any of you are not aware what a lagoon is, wastewater treatment lagoon is, I'll explain that, and then we'll see two major types of lagoons, and then we'll go to some of the features and characteristics of a wastewater treatment lagoon. And having known what a lagoon is, then we'll go for the process design for a lagoon project. In that, we'll see what are the important design considerations or parameters that a design engineer has to take into account when he's constructing a lagoon. And then we'll talk about some of the performance we expect from a lagoon, that is effluent goals. And then integral part of process design is developing process flow sheet or process flow diagram, Ph.D. And we'll see how to develop that. And then finally, the most important aspect I would say is the engineering economics, where we will develop alternatives and then we'll develop a cost estimate as accurate as possible. And a lagoon is basically a pond or a series of ponds where provides treatment of raw wastewater to acceptable quality so that the effluent can be discharged into streams or other water bodies such as rivers, lakes, or ocean. And it consists of a pond or series of ponds. So the first cell in a lagoon is usually for primary settling of solids, and some amount of biodegradation of the contaminants take place there. And the secondary or the third cell is where the major part of the biological degradation takes place. And the final cell is usually act as a clarifier where the suspended solids settle and the clarified effluent is discharged. Some of the common pollutants or parameters that we address in sewage is the biological oxygen demand, which is indicator of your organic strength of the wastewater, and total suspended solids, and ammonia, pathogens, which is indicated by E. coli bacteria, and the nutrients nitrogen and phosphorus, which are receiving great attention these days due to hypoxia problems and eutrophication. And the wastewater which is collected from a service area could be like residences, commercial buildings, or industries. It's first collected by the gravity sewer system, and either can be delivered to the lagoon, depends on the topography, or if your lagoon is going to be at a higher elevation, then the wastewater is conveyed to a pump station from where it's pumped to the lagoon. These are the two major types of lagoons. One is discharging and the other is non-overflowing or non-discharging. And you can see here, this picture, there's a lagoon cell and there's a simple water balance. The amount of inflow into the cell is the raw wastewater entering and also the rainfall. And the dissipation method is by evaporation as well as seepage through engineered soil liner, the bottom and the dikes. So if you have enough land area, then the first choice would be to build a total retention lagoon where your total dissipation, the amount of water dissipated is less than the amount of water entering into the lagoon cell. So there is no need to discharge, and there is no problem with environmental compliance and so. But when you don't have sufficient land area, then we have to discharge, and that's called like discharging lagoon. And there are several design parameters for that. And this picture shows a typical lagoon with two cells, and you can see like the dikes are protected from erosion by either placing rock riprap or concrete, which I'll show in the next picture. And from the first cell, the water is carried through pipes to control structures, which is shown by like white manhole, and to the second cell, and so on. And this picture shows a lagoon cell under construction. And here you can see instead of rock riprap, we can use concrete. And the other method is just to have a grass. So knowing what a lagoon is, let's jump to the process engineering design aspect for a lagoon project. And suppose we are going to design a lagoon, then what are the considerations, design considerations that we have to take into account? One of the important things is to know the amount of wastewater that is generated, and that's going to enter into your wastewater treatment facility or lagoon. And the second is the wastewater characteristics. And typically for sewage, it's pretty much uniform, but still you want to get the actual concentration by analyzing in a laboratory. And the third is land availability. Do you have enough land? And if you have enough land, then is it owned by your client, the city, or can it be purchased from the landowner? All those issues. And the prevailing wind direction. You want the prevailing wind direction to be opposite to residences. And in designing of wastewater treatment facilities, the regulatory authorities like the state, Kansas Department of Health and Environment, and EPA, Environmental Protection Agency, and local, sometimes even the county, they issue guidelines from time to time, and they have some minimum requirements as well as recommended guidelines. For example, in Kansas, you should have a minimum of 2 cells. In other states like Iowa, Nebraska, you can have like 1 cell, but Kansas, you must have a minimum 2 cells. And separation distances from residences, human habitats, it's to be minimum 500 feet. And from the nearest property line, your water line should be at least 100 feet from the nearest property line. And the lagoon should be protected from the 100-year floodplain. So all these considerations as a consulting engineer should take into account by getting information